Hey everyone, here's another example from section 2.2. We're going to try to find the limit as x approaches 3 for this function here. The first thing we're going to do is we're going to check to see is 3 actually part of the domain of this function, meaning if I plug 3 in to this function, does it actually give me a number or does it give me something that's undefined? So I plug 3 in, and that's going to give 3 minus 3 over 3 squared minus 9. 3 minus 3 is 0 over 9 minus 9, which is 0 over 0. This is undefined. We cannot divide by 0. So this function does not have a domain value of 3 because we're getting something that's undefined. So what do we have to do? We have to start with this, and we got to do some algebraic manipulation of this function, some sort of canceling or reordering of this function so that we can actually get something that we can evaluate at 3. The first thing you should always look at is factoring. So this is really equal to x minus 3. If it's x squared minus 9, I can break that up. This is a perfect square. I know that because of this whole minus 9 thing. Or sorry, I lied. It's not a perfect square, but I can factor it. So what I need to do is I need to break this down into two binomials. So I'm going to split this up as x, and then if I use plus 3 and minus 3 here, you can see that if I were to distribute this out, 3x and then negative 3x cancel out. That's why there's 0x in there, right? Nothing in the middle. 3 times negative 3 is negative 9, and x times x is x squared. So this is the exact same as this. So all I did was factor this into this term. But what do you notice? You see x minus 3 on top and on bottom. So I can cancel the x minus 3 on top and on bottom, and that's going to leave me with 1 left on top over x plus 3. Now I have a function. So this function, really simplified, gives me this function. So they're the same function. This is just simplified. Now if I evaluate this at x equals 3, that's going to give 1 over 3 plus 3, which is equal to 1 over 6. So my limit as x approaches 3 is 1/6. Now that doesn't mean that my function, like if I evaluate my function at 3, I'm going to have an open dot there, because when you evaluate the function at 3, you don't actually get 1/6, but as you approach 3, you're getting closer and closer to 1/6.